Today on Mosh Pit Garage, we're going to do a bunch of stuff. We're going to use the lathe, we're going to use the milling machine, we're going to rescue some old machining tooling. I'm going to keep on my fingers. Make or buy decisions can be complicated or they can be simple. For example, before I retired, I was working as a mechanical engineer at a research and development company, and we made some very high-end space instrumentation for NASA. In fact, I've got 4 things that are in space right now that I worked on. In that environment, you've got plenty of challenges to overcome. No need to make something that already exists. And that's what you might call a make or buy decision. Am I going to make this thing or am I going to buy it? And in most cases, if we could buy something that would do the job, that's what we would get. To integrate into some system that we were developing where most of the system was already custom things that we were making. And if we just needed, this is a simple example, but if we needed fasteners, I wasn't going to design my own thread system and make my own fasteners. There were a couple exceptions to that, but for the most part, we just bought them. In fact, McMaster loved us because I bought stuff from them all the time. Now, it can get more complicated if you have reasons for actually wanting to make something when the make or buy analysis would tell you to just buy it. And this is one of those cases, I think. So I'm in the process of setting up a fixturing bench for welding. I just picked one up, a used one off of Marketplace, and I'm putting together all the little bits and pieces that can help you set things up and weld them. One of those things I want to get are those V-block pins. I'll put a picture of those right here. Those V-blocks drop into the fixture table. They have a V cut into the top of them. And so you can set pieces of pipe and things on them like that to fixture them up and clamp them down so everything's held in place when you weld them. Those things are a dime a dozen on places like eBay and Amazon. I could buy those, but I think I'm going to make them. And there's a few reasons for that. One, I've already got the stock. I've got this big chunk of aluminum that was graciously given to me by a friend of mine, Mark, who is an outstanding machinist and mechanical engineer. So I've got the material. And 2, unlike Mark, I don't have a lot of experience with machining. I've got this lathe over here that's off camera and this milling machine right here that I should get some more practice with. I've had them for a while, but I don't use them that often. I do not consider myself to be a machinist by any stretch of the imagination. I have great respect for machinists. I work with some outstanding machinists for decades. At work, magicians, these guys. We gave them hard parts and they would make them. It makes sense because I'm going to get some practice in, and it's a relatively simple part. It doesn't have tight tolerances or weird geometry, or, you know, from what little I know about machining, looking forward through what I'm going to do to make them, I don't think it's going to be that hard. We'll see. So for those that are not familiar with what I mean by a fixturing table or a welding table, this is it. I don't remember the name of the company that makes this particular piece, but they are sold at Northern Tool. And basically what these things are tables made out of plate steel. This one in particular is fairly thick. I think this is 5/8 inch thick. Much thicker than the ones you see at places like Harbor Freight. Nothing wrong with those. I just wanted to get a thick one. Normally this goes for about $2,700 on the Northern Tool website. But I got this one used off Marketplace for $1,500 from a very nice guy who was a very experienced welder for the petroleum industry, who was going to be upgrading his setup. So the basic idea is that you have all of these 5/8 inch holes in here that allow you, and I believe these are in 2-inch increments, that allow you to do setups. So like, for example, these are pins that I turned down. They were normally meant for the thinner tables, so you put them in the hole and bolt them down. Can't bolt them to this one because it's thick, but you don't need to anyway. So I turned these, normally this thicker part, the 1-inch diameter, came all the way out to the threads here. I turned them down. You don't really need to bolt them down because once you put them in here, if they have any kind of side loading at all, they don't want to come out. They kind of jam into place, which is nice. So like, for example, if you wanted to position something on this table that you were going to weld, you could put these 2 pins in there, put this piece of plate up against it, and boom, it's indexed, you know. So if you're doing something over and over again, you could set up something like this. You could locate it in 3 positions by doing something like that. Boom, I can just drop it in there like that and you're good to go. And another thing they do is put clamps in it. So let's say I need to clamp this thing in place while I'm welding it. Let's say I'm going to do it something like that. This is basically just a pair of vice grips that have been welded to a pin. I just did these, so I haven't cleaned them up yet, but these are cotter pins that I ordered from McMaster Car with a 5/8 inch shoulder. You can set them like that to clamp something down, and now that thing is in there, and you can see this clamp is not coming out. It is in there. This is a clamp that you can adjust up and down. When you put an upward load on it, it binds into place, and then you adjust it up and down like that. I just went to Harbor Freight and bought these clamps, which originally looked like this, okay? Cut this off right here, cut this piece off right here, and then welded on another one of those cotter pins. And again, you turn it to lock something down. Pretty cool. So that's a welding fixture table, and there's a ton of YouTube channels where people use these. You can even build these things yourself if you want to. I mean, basically, you just need a very sturdy frame and a really thick piece of metal. And then you got to be able to drill a ton of holes. This is one of those things where when I made the make or buy decision, I went with buy. I really wasn't going to save that much, if at all, by the time I bought all the materials. We are going to start with the lathe. Now, this is a Victor 1640 lathe. This is what's called an engine lathe, pretty typical manual lathe. Came with all kinds of stuff, and basically I bought the milling machine and the lathe at the same time. Screaming deal. Came with tons of equipment that if I had bought it itself, all the tooling, it probably would have cost easily hundreds if not thousands of dollars. So it was great. And also this thing came in really good shape. The only thing I had to do was put some new drive belts on it. And of course, both these machines run on 3-phase power. I don't have 3-phase power available at my house, so I use what's called a rotary phase converter. This thing has about a 7 to 8 horsepower motor in it. So it would tear your hand off of your arm without even thinking about it. So yes, as with any piece of power equipment, especially with lathes, you got to treat these things with respect. I still have all my fingers and I want to keep it that way. So what I'm going to do is I'm going to take this bar, I'm going to do what's called some turning cuts on it to clean it up and give me a nice diameter. I'm going to have an exhaust fabrication job coming up soon. That'll be in a later video. Because exhaust pipe can, be up to 2.5 or 3 or even 4 inches in diameter, the wider these V-blocks are, the better. It's kind of shocking how much trouble I have finding things in this shop because I keep it so well organized. Here's one we can use. This is a quick change tool holder, which is kind of cool because you use these holders. All you have to do if you want to change tooling is pull one out, drop another one in, and turn that lever, and boom, it's in there. I think we're ready to start. Before I mentioned rotary phase converter, this is it right here. So I'm turning this on. This thing is basically filled with capacitors and whatnots, and is connected to this gigantic electric motor. And between these two things, it generates 3-phase power, which is routed over to the machine. Now what I'm doing is making sure I've got the feed set up, but I'm going to get a better finish if I let the machine move the cutting tool. And touch off on this, zero this indicator, and now by reading this, I'll know how deep my cut is. All right. Okay, let's see if this is going to work. Hey, there we go, we're cutting. I just love the look of freshly machined aluminum. It's beautiful. This bar is a little beat up on the outside, so that's why we're hearing that noise. Because the cut depth is fluctuating a little bit. You can set this up to cut towards the spindle or cut away from the spindle. I'm cutting away from the spindle so I don't have to worry about a collision. I'm going to clean these shavings off. These little cutting inserts, the carbide pieces, will have something on them that's called a chip breaker that's supposed to keep this from happening. Don't ask me why it's not doing it, but it's not doing it. Whatever. I think this is going to be the last cut before I flip the part. Okay. Let's get all these shavings cleared off. I'm going to take one more pass because I still think I'm going to end up with this being still at or slightly larger than this side, and I want this one smaller so I can turn it into the same diameter. Okay, now let's turn this around so I can cut the other side. Ooh, that's a little warm. See, nicely machined. Now it's got these little scrapes on there. That's just from the chips spinning around on this. I don't think this is going to be the final surface, so I'm not too concerned about that right now. So I'm touching that off. It's at 140 still. I'm going to reset this at 0 again, touching off on the surface. And I'm going to start by going in 20 just like before. And 20 and go. With carbide tooling, from what I understand, you either flood it with cutting fluid or you don't use it at all. Since this is just aluminum, I'm not using it at all. Because apparently, since carbide is extremely hard, but that also means it's extremely brittle, if you try and hit it with cooling fluid intermittently, that thermal shock will break the carbide. After running things on the lathe, this is one stop I have so far. So basically this is the finished OD here on the left from the big piece of bar stock. And then I turn that down to 5/8 so that it fits rather snugly. While pushing sideways on it, I'm trying to pull it out and it will not go. So that's great. That's exactly what I want. And then it occurred to me, since this is a welding bench, it would be nice to have a tungsten holder so that I can sharpen several tungstens in advance and have them ready to go in case I dip one. And it can also hold whatever welding rod I'm using at the moment. And the trick thing about this is that I've got this same interface on the bottom. So basically all this is a taller version of this piece that has been bored out in the center to accept these. And because of the bottom peg, I don't have to worry about it tipping over, even if I have these things leaning out sideways. I don't have the inserts that I really should be using for aluminum. Technically, the inserts I have are not for aluminum, they're for steel, but hey, they worked. I mean, considering that I'm a complete amateur at this, and that's the surface finish I ended up with, it's not bad, you know? And functionally, yeah, they're fine. Okay, this is another thing I picked up at auction, and I'm going to clean this up because I'm going to need it for making those V-blocks. What this is a device that lets you set up an angled surface on the XY table on the mill, which is great. So this piece right here mounts to the bench like that. And then you've got this part right here that allows the angle to be set in this direction. And then you can't see it right now because it's dirty, but there are graduation marks, angle graduation marks on this, so it can be rotated at an angle also. So it's a compound setup. It's nice. So I'm going to clean this up right now, try and get some of the rust off of it, reassemble it, and then set it up on the bench. Let's do that now. This stuff is great, but man, the nozzle really wants to gum up. Okay, disassembled. So now what I'm going to do is I'm going to go off camera, clean all this up with brake clean, and then show you how I'm going to get the rust off. Okay, once I wipe this guy down, that gets rid of the gunk. So I could probably lubricate and reassemble this thing right now, but since I've got it apart, I'm going to strike a middle ground between use it as is and full tool restoration. I am going to get the rust off of this, and to do that, we use this stuff, Evapo-Rust. Not sponsored by anyone, but I've used this stuff before. And it's amazing how well it works. When I originally bought all of this equipment, a lot of the tooling that came with the lathe and the mill was filthy. So after cleaning them all up, I ran hundreds of parts through this Evapo-Rust stuff, and it's pretty amazing how well it cleans them up. And to this day, they still look good. I like this stuff. So what I'm doing is I'm putting this in a bag because I can flood the part with a lot less of this stuff. This stuff's not cheap. 30 bucks a gallon at the local auto parts store. These are just large freezer bags. Now the other thing about this Evapo-Rust stuff is that it's not a one-shot deal. It can be reused over and over again as long as the chemistry is still there, not used up. You can leave this stuff in a container you were soaking it in, or pour it back into a bottle or into another bottle, whatever you want to do, and reuse it, which is pretty awesome. Whew! Man, I'm telling you people, Texas in the summer really sucks. It's hot. All right. This guy does not want to cooperate. I think he may have to go in the bath. So it says, 30 minutes for light rust, 12 to 24 hours for stubborn rust. So I'm going to give it a couple hours, come back and check it, and see how it is at that point. Some of these parts may not take very long at all. They are covered with rust, but the rust is not thick. Cheap Ziploc bags. The actual Ziploc brand was out of stock at the store, so I had to get the house brand stuff, which is not as good. Get that air out of there. So, let this soak. This part, I'm going to have to come back and do separately in this tub or something even larger once I pour off what's soaking right now. I'll be back. Hey, look at that rain. Man, we need it. Okay, let's see how it's going with these parts. We'll start with this one. And I can tell by looking at this, it's already considerably improved. Not that I'm trying to do it, but this label right here is actually looking much nicer. Almost looks new, except for the fact that it's got chunks of paint missing. And if I flip this over, look at that. There's still some little pock marks and whatnot, but this surface was covered with rust, this surface was covered with rust, and it's already much better. You can see now that that has more of a gray cast iron appearance to it, and it's not rusty looking. That's already pretty good. I may even stop it there. Okay, what else do we have? This is the pivot rod that I put inside, and yeah, that's good enough. I mean, look at that. You don't want to leave this stuff in this rust remover for too long because it can start eroding the metal. So leave it in there just long enough and then stop. I'm taking this out. This one I'm flipping over to let it soak on the other side for a little while. Let's take a look at this one. Man, I tell you what, look at this. HEB, your Ziploc bags suck. I'll pull this out. And yeah, there's still some surface rust here, like where it was in contact with the bag. But if you look at the cast iron surfaces again, like here, make sure that gets in focus. That looks pretty good. It's back to that gray cast iron looking finish. And the graduation marks for the angles, man, they have really popped out. Before I could barely tell they are there, and now, not only are they there, they are legible. Look at that. Not bad at all. Now this part still looks a little cruddy, but that's just paint, Wow, this one's done. Let's see how this one is. So this one, I think, is going to need a little longer. Though it's not bad. I don't think it was completely in the solution. That one also looks, well, this one looks pretty good. What's funny is before, I couldn't really see it very well, but somebody has repaired this. That's a weld there, weld here. So yeah, that actually looks all right. I think I'm going to stop this one as well. I'm going to put this one back in for a little while longer. And this is the last bag of stuff. This is that large circular flat plate. Yeah, look at that. So this has all gone to that gray cast iron look on the surface. That looks fine. And I think what little rust there is left on this side is just kind of down in the pits, so I'll be able to clean that off. But man, look at that. Doesn't look new, but man, the rust sure is gone. Now this stuff will turn dark as you use it, but you know, that's okay. That doesn't mean it's getting used up. And you know, by stuff, I mean the evaporust. Oh man, look at that. Those look good. Again, not new looking, but man, much better than they were. So this washer has some pitting and things on it, and there's some gunk down in the pitting, but that's fine. These are two machine blocks that were holding that large round plate I just pulled out. Those look great. It's a black oxide screw, and I've seen this before. I think the evaporust will take a little bit of the black oxide coating off of it. Pour this out before it leaks all over the bench. Man, that's a few dollars a solution right there, right? I think I may just go ahead and stop this one. That's not so much rust as it is just surface dirt. Yeah, it looks like they even used, I'm starting to see some color in this now. So that looks like that might be phosphor bronze. This is a cast part, and phosphor bronze is a welding material that is commonly used to fix cast parts. That's what that looks like right there. Structurally speaking, they did an okay job of repairing that part. Okay, so basically I just poured the rest of the evaporust into here so I didn't lose it to leaking Ziploc bags anymore. There it is. I don't think it ever made it into a bath. This stuff is a little irritating. I can feel a mild burn on my hands. May cause skin and eye irritation. Avoid contact with skin and eyes. Wear gloves and eye protection while using. Wash hands after handling. Do not store blah, 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 blah. Okay, yeah, so I didn't wear gloves. Wear gloves. So I forgot to mention that this stuff is water soluble. So you can just rinse this with water, and then of course you want to dry it right away so it doesn't flash rust. This one's been repaired. This looks like an actual steel alloy of some sort. And the welding is a little pooky, but to the welder's credit, whoever they may be, apparently some of these cast iron compatible repair weld materials can be gummy and hard to weld. So don't hold that against them. Okay, here we are back to this part. Yeah, this one's done too. That looks great. I'm happy with that. Let's rinse it off and lube it up. What about this big old thing? I guess what I'm gonna have to do is immerse it. Oh, look at that. I didn't think it would fit in there, but it does. That's great. All right, so now we'll let this guy soak for a couple hours. There's another indexing mark that I hadn't noticed until now. Check that out. Okay, last part, that big one. I'm going to take it out, see how it looks. Looking good. Now look at that. You can see the hard line from where it was submerged and the rust has been removed, and where it wasn't and the rust is still there. So that is a decent before after shot right there. I'm gonna flip this over and we're gonna keep it going. I have removed the last piece from the evapor rust, rinsed it off in water, so I don't need my gloves anymore. We're done with the evapor rust. I'm gonna clean this up. There's some more indexing marks right here, and that's for the tilt this way that pivots on that large rod. I'm going to finish drying it and then we're going to assemble it. This is the stuff I'm using right here. It's a rust protectant and lubricant. Again, no sponsorship here. This is just what I'm using. This stuff is pretty thick and it really likes to gum up the sprayer. So it's like every once in a while you kind of have to pull this nozzle out, do a magic dance, cross your tongue sideways, click your heels together, and then it should work again. This stuff kind of smells like Harbor Freight when you walk in. You know, that gunk that they put all over everything so it won't rust. I'll bet you whatever Harbor Freight uses, whatever their Chinese vendors use, is very much like this stuff. Okay, assembled. And it doesn't look new, but boy, it looks a whole lot better than it did. I am glad I cleaned this up. And you'll notice that on the side here, there's a mark right there that tells you when you're at 90 degrees. We will be using it at 45 degrees. So basically it will be on the milling table like this. And then the work can be clamped to this surface right here. I think that does it for today. Next, we'll be setting this up on the lathe to take some cuts.
Watch out, Michael Ackerfield, I'm coming for you.
I have set the rotational angle to 90 degrees. So, I've got this set at a 45-degree angle. This rotation is normal to the table. Now what I need is a clamp to hold the workpiece, and though I've got one of those giant Kurt vices, oh God, the spacing isn't big enough. Okay, we're not using the Kurt vise. I think that's going to be a little too wieldy for this, so I'm going to go with something smaller and see how that works. Okay, the hole placement is right. Let's see if we can get this to work. This is all stuff that came with the equipment. The way this stuff works is there are these standardized T-slots shaped like a T, and you use these T-nuts and these slots. You slide something in here, tighten it down, lock it in place. Works great. When you're getting parts quoted, keep in mind that machinists have to do what's called setup. Setup is what I'm doing right now. You know, these machines, whether it be a manual lathe like this or a CNC device, they're configured to do lots of things. And so when you come to a machinist with job X, they can't just take your part, throw it onto and start cutting away on it. No, you got to do what's called setup, and that's what all this is, and this takes time. So if you wonder why machining is expensive, unless you're just like getting a hole drilled or something silly like that, this is where the money goes. A good machinist is a valuable commodity. One thing about buying this old tooling is a lot of this stuff made in USA. Woo! The more American the name of the tool company sounds, the more likely it's Chinese. Pittsburgh Tools in Harbor Freight, Chinese. I am going to try this and see if it works. I'll keep an eye on it. If it starts slipping, I will stop. So I've got these guys, which are soft jaws, that really are intended to be used for AN fittings. And they are kind of tall, and they are not going to work for this. I'm sorry, sir, that is the incorrect answer. Problem is, if I just clamp this in here, a couple of things are going to happen. One, I'm going to have to clamp the crap out of it. And if I do that, it's going to booger up this, because this is just aluminum, it's soft. And it may not want to go in the hole anymore. That's what, never mind. These jaws on this little baby vise aren't very aggressive. Actually, I don't see much marring. Let's give this a shot. What could possibly go wrong? It's just a 2.5 horsepower milling machine spinning at high speeds with sharp stuff hanging underneath it. Okay, now next question is, what am I going to cut this with? So I have a assortment of end mills here, including a fairly large one. This is a 3/4 inch. That could work. And then I also have this fly cutting tool right here. This is used as, this has carbide inserts. This is almost certainly high-speed steel. Let's get going. I'm tired of talking and setting up. There's a rack of a bunch of collets over there, at least all the ones that came with the machine. This one is actually a Bridgeport collet. Look at that. Bridgeport. USA. Pretty cool. Guess that's one thing about it, all these old tools, like I was saying earlier. All right, so 3/4 inch. This has a 3/4 inch shank. So what that means is this hole, this collet, is sized to accept that tool. And the way it works is you put it up inside of the spindle, and a threaded rod comes down from above, grabs this, pulls it up, and you see how this is tapered right there? There's a taper inside of the machine also. So when you pull this up, this taper gets squeezed and grabs the tool. In fact, that squeezing is why these things have slots, so they can collapse down. Okay, we're cutting. Finally. It's working. Right. Now if you're wondering why I'm not using my DRO, digital readout, it's on the fritz right now. After a recent lightning storm, it decided to stop working. So I've got to take that guy apart. Happy little chips flying through the air. What if Bob Ross had been a machinist? I'm going to make sure that nothing is coming loose. Everything seems fine. All right, let's keep going. Voila! That's not even that hot. And there you go. We have a V-block. Now it needs a little deburring, which I'll take care of with the file. So it didn't rotate in the vise, which I'm kind of shocked about that actually. Now I was feeding it a little on the quick side, so you can see the machining marks there, but I'm not worried about that. In fact, if anything, those are going to help grip the pipe. You know what? I'm happy with that. That's going to be all right. So the whole point of setting this up at 45 degrees was I could cut both of these sides in one shot. With this tilted at 45 degrees, when it's tilted back up again, I have two 45-degree cuts. That was the idea, and it worked. Okay, awesome. I'm happy with that. Let's give this a trial run. All right, so this guy drops down on the table like so. And let's say I want to fixture this piece of pipe. I'm going to weld it. That drops in there like that. I drop this clamp into place. Tighten it up. Boom. That piece is locked in there. that's what it's supposed to do. It's working. So if you can imagine, I was going to butt weld a couple of pieces of pipe. I had another one just like this one, bring it in like this and weld it. I would have another one of these back here to hold this pipe, and then two of them up here to hold this pipe, put them together, clamp both of them down, and then I can tack them up and weld them. It's going to hold everything into position. So it worked. Not bad for an amateur machinist. We can call this mission accomplished. I'm happy with this. All right. Now I just need to make some more. So basically I'll just duplicate this. I'll turn some more pieces in the lathe. It'll look just like this before I cut the V-notch in it. I'll take some measurements of this part so I can duplicate it. And then I'll leave the setup in the milling machine. I don't have any other jobs coming up for it, so I won't have to tear it down and set it back up again, even though that was so much fun. And make more of these. I will probably make at least 3 more, maybe 5 more, so I'll have 6. We'll see. All right.